Hi, in this video I'm going to demonstrate how to run a K1C test. Before running the test, let's first take a look at the equipment we are going to use, which is the MTS 810 Material Test System, also called UTM, Universal Testing Machine. Because with different type of the features, we can run different type of failure tests, such as K1C, fracture crack growth test, and high cycle, low cycle fatigue test. Here, you can see we have the K1C specimen on the left and the fatigue sample, the cylindrical dog bone on the right. The testing system has several main components like the hydraulic power unit here, providing the load source. In the middle, it has this wide crosshead holding the actuator driven by the hydraulic power unit to apply the load to the samples. The load arm of the actuator can be programmed to move in a single direction or in a reciprocating motion under desired frequency and load. For the K1C test, we need to connect a measuring instrument, which is this COD gauge, to measure the crack length during the test. We will talk about it later. On the left, we have the computer, which has the testing software installed, and the control unit, which is a data acquisition system. These two units generate the control signal to the mechanical components of the testing frame. Now we know the basic information of this machine. Next, let's talk about the K1C test. Here is a K1C specimen. It is a compact test sample, which the dimensions follow the ASTM E399 standard. As you can see, this specimen has a machined V notch. It's for guiding the crack growth direction, since the load applied is concentrated at the tip of the notch. Again, following ASTM E399 standard, to assure the final fracture is all the way through the center of the specimen, other than the V notch, we need to pre-crack the specimen first by applying a cyclic load for a period of time. The peak of this load need to be over the yield strength of the material. Then the pre-crack is going to initiate and propagate from the tip of the V notch. The COD gauge is mounted at the opening of the notch for detecting the displacement increasing of the opening in order to calculate the length of the pre-crack. Because the maximum opening of the notch under amount of load is going to bigger and bigger when that pre-crack increases. As long as you know the relation between them, you can calculate the pre-crack length based on the COD measurement. Luckily, the testing software will do this work for us. The testing software will stop the pre-cracking cyclic load after detecting the pre-crack reaches the target length. Then, the K1C test needs to be executed by applying a constant load until the specimen breaks into two pieces. Alright, let's set up the software, then install the specimen to run the test. Here we are going to use the MTS fracture toughness testware, which has 4 main steps. First, we need to measure and define the specimen that is going to be tested. Then we define the test, which means program the control of the test, such as the frequency and the range of the cyclic load for pre-cracking. After that, we can execute the test, which is pre-cracking first, then applying constant load to break the sample. Lastly, we analyze the testing results. In this step, we need to do some final measurements also with some adjustments to have the final report generated. Now let's first take a look at the define specimen step. I'm going to edit my test based on our previous test. Then, in the window popped out, you can see on the left, we have this picture for reference about the measurements, such as where to measure the width, the thickness, and also like a pre-crack. This is super important. On the right of the window is where you need to input all these measurements and also input some information like yield strength, ultimate strength. These should be measured from a tensile test of your material. And also something like a Poisson ratio and Young's modulus. These can come from like a value of the normal materials. Then we save the settings and ready for the next step, which is for define the test or set up the software to control the test for both pre-cracking procedure and the final fracture. For example, set up the pre-cracking procedure by defining the cyclic load range, like the frequency, and the most important, set up the target final length of the pre-crack. In the ASTM E399 standard, it should be between 0.45 W to 0.55 W, which means if the width W is 2 inches, then the target pre-crack should be between 0.9 inches to 1.1 inches. Normally, we set up here to a middle value, which is 1 inch. In this demo, you may notice it was set to 1.1 inch, which is the upper limit. It's not a normal setting. I was running some tests. I didn't change it in the demo. Okay, after setting for pre-cracking, we need also define the load ramping rate for the K1C test. So the fracture is controlled in a load constant increasing way. Also, we need to define the condition to terminate the test after the fracture happens. Here it's set when the COD displacement reaches its maximum range, which means it detaches from the opening of the specimen, which is the sign that the sample is fully fractured. Alright, after they find the sample and also they find the testing procedure, I'm going to install the sample or specimen onto the fixture and then continue execute the pre-cracking and then the K1C constant load increasing test until the specimen is fractured. I will stop the video here and come back after the installation. Okay, now the sample is installed and also the COD gauge is mounted on the opening of the sample specimen. Now we can go back to the software to execute the tests. Of course, like many other tests, there are more things need to be done before running the test, such as zero the load, zero the gauge, and so on. I will not waste too much time on these details in this video, right? So, okay, we are in the execute window now. Here you can see the pre-cracking is first selected, so it's the first step after clicking the run button on this window. Here I also opened two displays to monitor the test, the pre-cracking procedure, such as the percentage of the pre-cracking has been done to before click the run button. Then I'm going to double check everything again, zero the COD gauge. Then I'm going to click the run button and start the test. Okay, the button is clicked, and then you can see this display here, or indicator here shows the cyclic load is applying on the sample spaceman right now. Back to the testing frame, you will see the fixture is moving up and down. And here is another angle, you can see it more clearly. From the monitor we were opened, you can see now, when you refresh the updated indicator, you can see the crack is changing. At the beginning, it is in like a negative percentage. It's common. With the time going, eventually you will see it's increasing like 50%, 90%, 100%. Usually it takes about 20 minutes to hours, depends on how tough the spaceman is. Now here, after about 6,000 cycles, the pre-crack grows about 15%. We'll come back when it's finished. Now it's almost 30,000 cycles now, and as I mentioned, you can see the load applied has dropped significantly since the pre-cracking is growing, so which means the sample is weaker right now. Alright, the pre-cracking procedure has been done. You can see the window popped out showing the target length has been reached. Then we need to click the OK button, go to the next step to evaluate this pre-crack by select from the action or option and then crack checking procedure. So here, you just basically click the ramp button, so the load will be applied on the spaceman, and after that you can see here we have the pre-crack length remeasured as 1.1084 inch. So it's pretty accurate pre-cracking procedure, very close to the 1.1 target. But again, as I mentioned, so for a normal test, the pre-cracking length will based on your width. If it's a 2 inches width sample, the maximum pre-crack should be less than 1.1. But I mean, as I mentioned, this is just for demonstration. Okay, let's select the real K1C test. First, open different indicators to monitor the K1C test procedure. Then we will click the run button. So then after that, a constant load will be applied on the spaceman until it's fractured. The button has been clicked. You can see the plot, which is the load versus COD displacement. You can see the opening is increasing, the load is increasing, and soon the sample will be broken. This K1C test is usually very fast. The plot is starting curving right now, so which is an indication that soon the sample is going to be broken.
It will, yeah, it passed the yield and it just break the sample.
The K1C test is terminated. Then we go to the Analyze option, select the tested data just now, then plot the test and check the results. Here is the plot of a load versus COD gauge, but we need to do some adjustment later. So then the plot will actually change based on these adjustments. So then, I mean, after that, we will have a final version of the plot. The first adjustment here is to recalculate the pre-crack, since as you can see here, the front of the crack is not a straight line but a curvature. We need to measure 5 places along the width of the specimen to get the average pre-crack length. As you can see in the summary, you need to input A1 to A5, which are measured on both of the 2 edges, center area, and also 2 quarter locations along the width. Lastly is to change the curve fitting range in order to find the accurate linear fitting for the load versus COD plot. As a result, we get a more accurate 5% second line for the finding of the KQ. After applying all these adjustments, we can now have the final version of the report with all the results for the future analysis. Here as an example, we have the most important value of this test, the KQ, and it could be the K1C if the test condition meets all the K1C requirements. Alright, this is a brief procedure of a K1C test. I will share some examples of the final testing reports with you later. Thank you for watching.